Hello everyone. In this tutorial I will complete the topic of domain and range of a function. We reach number 6. If there is a quadratic function under square root, like f of x equal to x power 2 minus r power 2. R here is a real number. Then the domain of this function is negative infinity to negative r union r to positive infinity. If we analyze the term under the square root as difference of 2 square, x minus r, x plus r, then x equal to r and x equal to negative r. We take the domain as negative infinity to minimum value of x, negative r, union r maximum value of x to positive infinity. For the range, if the root preceded by positive, then it is 0 to infinity. If the root preceded by negative, then we have a reflection by x-axis and the range will be negative infinity to 0. Example, find the domain and range of the function x square root x power 2 minus 25. Then the domain is negative infinity, open bracket, to negative 5, close bracket, union 5 to positive infinity. Since the root preceded by positive, then the range is 0 to positive infinity. Example, find domain and range of the function negative square root x power 2 minus 4. Then the domain is negative infinity to negative 2 union 2 to positive infinity. For the range, since the root preceded by negative, then the range is negative infinity to 0. The graph of this function is, this is 2, this is negative 2. The join point in the domain, 2 to infinity, negative 2, negative infinity to negative 2. And the range from negative infinity to 0. For the first example, the graph is, this is 5, this is negative 5, from 5 to infinity, union negative infinity to 5, and the range is from 0 to positive infinity. Example, find domain and range of the function square root x power 2 minus x minus 6. Here we don't have a difference of 2 square term in the under square root, but we have a quadratic function. We can analyze it as x minus 3 difference of 2 square by experiment, x minus 3, x plus 2. Then the value of x here, x minus 3 equals 0, it means x equals 3, or x plus 2 equals 0, x equals negative 2. Then the domain will be negative infinity to minimum value of x, negative 2, union maximum value of x to positive infinity. And the range, since the root preceded by positive, will be 0 to positive infinity. Example, find the domain and range of the following function negative square root x power 2 plus 7x plus 12. Also, I can analyze the term under the square root by experiment as x plus 3, x plus 4. Then the value of x here, x equal negative 3, x equal negative 4. The domain will be negative infinity to minimum value of x minus 4 or negative 4 union maximum value of x to positive infinity. The range, since it is preceded by negative, it will be negative infinity to 0. Open bracket. If there is a quadratic term under square root as f of x equal r square minus x square, not x square minus r square. Also, I can analyze this term by difference of two square as r minus x, r plus x. Then the domain will be negative r to r, close interval, and the range will be 0 to r. Example, find the domain and range of the function square root 16 minus x squared. 16 minus x squared is analyzed as r minus x and r plus x. Then the domain will be, 4 minus x, 4 plus x. Then the domain will be negative r, negative 4 to 4, and the range will be, since the root preceded by positive, from 0 to r. The graph of this function will be 0 to 4, this is 0, this is 4, this is 4, this is negative 4. It will be as a half circle. The domain from negative 4 to 4 and the range from 0 to 4. Example, find the domain and range of the function negative square root 1 minus x. Also, I can analyze 1 minus x square, 1 minus x, 1 plus x. Then the domain will be negative 1 to 1, and the range, since the root preceded by negative, it will be negative infinity, negative 1 to 0. Then the graph, since we have the root preceded by negative, we have a reflection by x-axis. This is 1, this is negative 1, and this is negative 1, and the graph will be like this, a half circle under x-axis, the domain from negative 1 to 1 and the range from negative 1 to 0. Number 7, domain and range of the absolute value function. The domain of any absolute value function, absolute value of f of x, is generally the same of the domain of the function f of x. It means I find the domain of the f of x as we studied before, and the domain of the absolute value is the same the domain of f of x. For example, find domain and range of the function f of x equal 2 over absolute value x plus 1. X plus 1, it is linear function. Its domain is r, all real number. But since it is in the denominator, then I remove the value that makes the denominator 0. Here, if I set x plus 1 equals 0, then x will be negative 1. Then the domain will be all real number except negative 1, since negative 1 makes the denominator 0. For the range, As we know, the absolute value range is from 0 to positive infinity. Since the constant in the numerator is positive. Example, find dominant range of the function f of x equal -1 over absolute value x minus 3. X minus 3 also is linear function. Its domain is R, but since it is in the denominator, the value make x minus 3 0 is 3, then I subtract 3 from the real number. For the range, since I have -1 in the numerator, then all the range will be negative, or the function reflected by x-axis, and the range will be negative infinity to 0. Number 7, domain and range of logarithmic function. F of x equal len g of x. For the domain, since the len is defined only for the positive number, then I'll set g of x greater than 0 and solve this inequality for x to find the domain. For the range is all real number. Example, find domain and range of the following function. F of x equal len x minus 2. I'll set x minus 2 greater than 0, since the len defined only for positive numbers, then x greater than 2. Then the domain will be 2 to infinity, to positive infinity. Open a bracket from both sides. Since 2, it is not in the domain. For the range is from negative infinity, open a bracket, to positive infinity. Example, find domain and range of the function len x equal 2x plus 6. Set 2x plus 6 greater than 0 and solve this inequality for x. 2x greater than negative 6, x greater than negative 6 over 2 equal 3. Then the domain will be 3 to positive infinity, and the range all real number from negative infinity to positive infinity. Sorry, negative 3. Negative 3 to positive infinity is the domain of this function. Example, find domain and range of the function f of x equal -5 over len 5 minus 2x. Here we have the len in the denominator, then it is different. First, I'll solve the inequality 5 minus 2x greater than 0, since len is defined only for positive number. Then 5 greater than 2x, then 5 over 2 greater than x, or x less than 5 over 2. Now, since len 1 is 0 and len is in the denominator, then 5 minus 2x should not be 1, should not be equal to 1. Then I'll subtract 1 from this interval. Let me find the value, make 5 minus 2x equal 1. Then 5 minus 1 equal 2x. Then 4 equal 2x. Then x equal 2. The domain will be x less than 5 over 2. It means negative infinity to 5 over 2. Except 2. Since 2 belong to this interval, then and make the denominator 0, then I subtract it. I can also rewrite this interval, this domain as negative infinity to 2 union 2 to 5 over 2. For the range, I set y equal to 5, negative 5 over ln 5 minus 2x cross multiplication, y ln 5 minus 2x equal negative 5, divide by y, ln 5 minus 2x equal negative 5 over y, take exponential for the both sides, exponential will remove the ln, then 5 minus 2x equal to e to the negative 5 over y, then 2x equal to negative 2x equal to negative 5 plus e to the negative 5 over y, then x equal to negative 5 plus e to the negative 5 over y over negative 2. Since y here is in the denominator, then when y equals 0, x will be undefined. Then I should remove 0 from the real number for the range. Then the range will be r except 0, since y is in the denominator and should not be 0. Example 4. Find domain and range for this function. Solve 4 minus x greater than 0 for x, then 4 greater than x or x less than 4. Solve 4 minus x equal 1 to find the value makes the denominator 0. 4 minus 1 equal x or x equal 3. Then the domain will be negative infinity to 3 union 3 to 4. Or we can write x less than 4, it means negative infinity to 4 except 3, since 3 belong to this interval and make the denominator 0. For the range is the same the previous example. It will be r except 0, since y in the denominator also. Number 8, find how to find domain and range of the piecewise function. For the domain, find the domain of each segment, then the overall domain will be the union of these intervals. Also, for the range, find the range of each segment, and the overall range will be the union of these intervals. Example, find domain and range of the following two functions. F of x equal 1 minus x when x less than 1, square root x minus 1 when x greater than or equal to 1. The domain of the first segment is x less than 1. It is negative infinity to 1, open interval from negative infinity to 1. X greater than 1, then here the interval is 1 to positive infinity. With 1, I set closed interval. The union of these two intervals, if I set the number line, the joint point 1, negative infinity to 1 without 1, and 1 to positive infinity with 1. Then the union of these two intervals is negative infinity to 1 union 1 to positive infinity equal to negative infinity to positive infinity, all real number. For the range, here we have a linear function. Its domain is R, but since its range is dependent on the domain, since the domain started from negative infinity up to 1, the maximum value is 1. Then 1 minus 1, 0. Then the maximum value for this segment is 0 without 0 to positive infinity. Since 1 is not in the domain, then 0, it will be not in the range. Union, the minimum value here is 1. 1 minus 1, 0. Then the minimum value in the range will be 0 to infinity, since the root preceded by positive. The union of these two intervals, 0 to infinity, union open interval 0 to infinity, union closed interval 0 to infinity, it will be 0 to infinity close interval from the side of 0. Another example, f of x equal to 3 minus x when x less than 3, negative square root x minus 3 when x greater than 3. This interval is x less than 3, then it is negative infinity to 3, open interval. For this segment is x greater than 3, it is from 3 to positive infinity, also open interval. Then the domain of this function is negative infinity to 3, union 3 to positive infinity equal to negative infinity to positive infinity except 3. Since 3 it is not belong to this interval and not belong to this interval. So the domain is all real number except 3. Also, I can rewrite this as negative r except 3. For the range of f, for this interval, when x equal to 3, then 3 minus 3 is 0. Then the range will start with the 0 up to negative infinity. 3 minus infinity, it is infinity. Then it will be 0 to infinity. Union 3 minus 3, 0. Square root 0 is 0 to infinity. Infinity minus 3, infinity, square root infinity, infinity, negative times infinity, negative infinity. Then the union of these two intervals is 0 to infinity plus negative infinity, I will write negative infinity to 0. Then it will be r except 0. Since 0 not belong to this interval and not belong to this interval. Number 9, domain and range of trigonometric function. We will study 6 of the more uses trigonometric function. F of x equal a sine bx. A and b are constants. Then the domain is R, and the range is from negative a to a close interval. F of x equal a cosine bx. then the domain is also R, and the range is also closed interval from negative A to A. F of x equal tan x. The domain is x, where x not equal to pi over 2 plus k pi, where chi is integer number. And the range is R, or real number. But I'll comment in this domain of the tan, since tan is sine x over cosine x, and the cosine is in the denominator, then should not be 0. I'll seek for a point that make cosine 0 and remove it from the domain. As you know, the graph of the cosine is from negative infinity to infinity, and it is a periodic function. The points make cosine 0 are pi over 2, 3 pi over 2, and so on, 5 pi over 2, and so on. If I want to make an equation or formula for this point, then I'll set pi over 2 plus k pi, where k is the integer number from 0 to infinity. When k equals 0, then x equal pi over 2, the first point here from the right. When k equal 1 is pi over 2 plus pi. Pi over 2 plus pi is 3 pi over 2. When k equal 2 is pi over 2 over 2 plus 2 pi. Pi over 2 plus 2 pi is 5 pi over 2, and so on. Therefore, the domain of the tan, all point except those make cosine 0, pi over 2 plus k pi to infinity. Also, I may be negative numbers, since there is negative numbers make the cosine 0. Number 4, f of x equal a over sine x. Then the domain will be all real number except those make sine 0. The point make sine 0 are, this is the graph of the sine, 0, pi, and 2 pi, 3 pi, 4 pi, and so on. Then if I want to make or to form an equation for this point, then I set k pi, where k is any integer number, x equal k pi. When k equals 0, then x equals 0. When k equal 1, x equal pi. When k equal 2, 2 pi. When k equal negative 1, negative pi, and so on. Therefore, the domain of a over sine x is all real number except x equal k pi. For the range is from negative infinity to negative a, union a to positive infinity. Number 5, a, f of x equal a over cosine x. The domain is also all real number except those make cosine 0, pi over 2 over plus k pi. And the range is also from negative infinity to negative a, union a to positive infinity. The last trigonometric function, f of x equal a over tan x. Since tan is sine over cosine, then it will be a over sine x over cosine x equal to a cosine x over sine x. Then the domain is all real number except those make sine 0. Therefore, all x where x not equal to k pi, or I except x equal k pi, where k is an integer number and the range is the same range of the tan function, all real number from negative infinity to infinity. Example, find domain and range for the following function. F of x equal to cosine pi x. The domain of cosine is always r. The range of this function is from negative 2 to 2. The range affected by the number that multiply by the cosine theta. Pi here it doesn't affect by the range or by the domain. The number or the constant that affected by the range is the number multiplied by the cosine or sine function. F of x equal negative 3 cosine 2x. Also the domain is all real number and the range is from negative 3 to 3. The negative is here is it doesn't affect by the function since it is from negative a to a. If we said negative 3, it will be 3 to negative 3, and since when we write the interval we start with the minimum point, then we write from negative 3 to 3. F of x equal sine pi x. The domain of sine is always a real number and the range is dependent on the constant multiplied by the sine is from negative 5 to 5. For sine x, also the domain is all real number and the range is from negative 4 to 4 close interval. Number 5, f of x equals 6 tan pi x. For the domain, I'll set pi x equal to, since tan is sine over cosine, then pi x should not be equal to pi over 2 plus k pi. Point thus make cosine 0. Then I find the value of x here, divide by pi, then x not equal to pi over 2 over pi plus k pi over pi. Pi with pi, pi with pi, then x not equal to 1/2 plus k. Then the domain is x, where x not equal to 1/2 plus k, where k is any integer number. And the range is the same range of the tan function, all real number. F of x equal negative 7 tan 2x. The domain, I set 2x not equal to pi over 2 plus k pi. Divide by 2, then x not equal pi over 4 plus k pi over 2. Then the domain will be x, where x not equal to pi over 4 plus k pi over 2. K is any integer number. And the range of f is all real number. F of x equal negative 1 over sine 2 pi x. Domain of f equal to, I said 2 pi x equal, not equal to point make sine 0. It is, they are k pi. Find the value of x here. X not equal to, divide by 2 pi, then k pi over 2 pi equal to k over 2. Then the domain is all x, where x not equal to k over 2, k is any integer number. The range of this function is range of f equal to negative infinity to negative 1 union 1 to positive infinity. Number 8, f of x equal 5 over cosine 2 pi x. For the domain, I'll set 2 pi x not equal to pi over 2 plus k pi, and find the value of x. X not equal to pi over 2 divided by 2 pi plus k pi divided by 2 pi. 5. The answer is x not equal to 1 over 4 plus k over 2. Then the domain of f equal to x, where x not equal to 1 over 4 plus k over 2, where k is any integer number. The range of this function is apply the rule of constant over cosine. It is from negative infinity to negative 5 union 5 to positive infinity. Number 9, f of x equal 2 over tan pi x. Tan pi x, we can rewrite this function as 2 sine over cosine. It will be 2 cosine pi x over sine pi x. Then the domain will be set pi x equal to k pi, pi with pi, x equal k. All x where x not equal to k, k is any integer number. For the range of f, it is all real number. See you next lesson.